Hello friends, welcome to Numpy. In this video we are going to learn full Numpy topics with applied some numericals also. We are going to create some programs also. Okay, I'm sure that not a single topic will be left behind from us. Okay, so let's start it. First the introduction. See, Numpy is a Python library. Simple. We are working with the arrays, or you can say lists. Okay, so it's open source. It is created by Travis Oliphant. Why it is created? We have already list why it is created. See, list has some limitations when it comes to some operations like linear algebra and Fourier transform and matrices. So it is something like complicated. To overcome that complicated, Numpy is a library. It has some built-in functions which can be used in linear algebras and Fourier transform and matrices. Now, Numpy stands for Numerical Python. Numerical Python, maybe it skipped due to it is working with the numbers. Maybe Numerical Python, yeah, it sounds better. Okay, now why we use Numpy instead of list? See, we can use list and Numpy for similar operations, but when it comes to the time complexity, so the list is slower than Numpy. Traditional Python list, okay, it is slower. The array object in Numpy is called ndarray. Numpy uses the object-oriented programming, while list is a traditional method. Okay, so it is high-speed array. I mean, the array it has a high speed, and more resources can be done within a short term of time. My question: why we use list, or why it is faster? Like Numpy, why the Numpy is faster than list? See, Numpy stores the data in continuous place in the memory, and like list, it has certain gaps between that. Okay, in the process or accessing or reading the data from memory, it is easier or quicker for the Numpy to do that. Okay, so Numpy is a Python library, and it is not fully written in Python. It is written in C or C++. Why is it so? See, Python uses interpreter which works like line by line. Okay, after the line by line process, it will execute also line by line. Okay, but in C and C++, it runs the whole program at one go, which is very faster than Python. Okay, if you want the repository like original code or source code of that Numpy, you can visit this link. It is github.com numpy or /numpy. Got? Yeah, let's move on. Okay, let's start. First of all, you have to import the Numpy. Import Numpy. We get a variable. We assign a variable as np, which is numerical Python, like short form np. Okay, so we have to create a variable in which we have to call this an object. Okay, we have to create an object in which we have to insert a list. Good. If we print it, like we have to execute it. We're starting right. Okay, let me copy this simply and paste it over here, and we are going to run it. Sorry, wait. Let me clear this out and go. Yeah. So let me slide this. So what we got? It's a list, right? But can you please concentrate? Is there like a comma in between that? Now we are going to print a list. Okay, I'm going to create a list which is same. Just copying that and pasting over here, and I'm going to print the list. Okay, now let's see the difference. So now, can you see the difference? We have the first one is the array, and the second one is a list. Got the point? Okay, so this is how we are going to create a Numpy like an array. We are going to use it over here. Okay, it's a starting one, and the basic one you have to learn that. Okay, let's move on. So the second one is version. How to print the version? Simply import Numpy as np, and we have to print np underscore version underscore. So when we run this, like same thing, copy and paste. There's some syntax error. So yeah, okay, we have the version 2.3.2. Make sure you have this. Okay, before that, how to install it? I'm sorry, I forgot that. So if you're not installed previously, so don't worry, man. Simply go to your terminal, right? Simply go to your terminal, hit install Numpy. That's it, and simply enter. And make sure you are connected with the internet. I mean, network of networks. Yeah. Okay, requirement already satisfied. Means I already have that library in my device. Next, what is this ndarray? What is that? Let's see. It's the type. If you're creating an object, an array in the Numpy, it is not a list. It has to give a data type, right? I mean, it's a type of that array. If you print or run that, if you run that, it should show what is that? It's a Numpy and array. It's an array which is used in Numpy, right? Let's move on. It's a pretty basic one. If you don't remember that, yeah, it will work. Okay. So how we, like, what is the dimensions in an array, or we can say in a list? See, I'm having a matrix. Okay, just imagine here is a square bracket with a long one. Okay, it's just how we represent it in a list. How we represent it inside a list, we will take each row as a list, right? It is called as nested list. But here we are simply going to print that. So what we are going to get? So what I'm going to get? It's, oh sorry, what's the problem? Now it's good. We are having each row, right? It is now look like a array, like matrix. Now, understood? This is called a nested array or nested list. Same thing. Let's move on. Let's erase this. Next, what is zero dimension? Now, here I have to mention something. Here, what is the number of rows here? It is 3, and number of columns is 4. We will write that as 3 into 4, right? 3 multiplied by 4, which has 3 row in column. We can say like that. 3 rows and 4 columns. This matrix has. It's needed for the further. Like in matrix, sorry, in Numpy, we have this dimension. Like, so if you want to create a list like a matrix one, what is the dimension for that? Nothing. Yeah, let's print this. I created a num array which has a 1D element. It's not a list, it's only the element, which is 44. Let's run that. Let's run this. We have this 44. Why so? It has a dimension of 0. Why? That's why it is called as 0 dimension. Next, we have the 1 dimension. An array that has 0 dimension has itself element is called unidimension. And okay, you got it. Okay, so we are having a unidimension. It has only one row. Like you remember the physics one, like 1 dimension, 2 dimension, 3 dimension, same thing applies here. It has one row and we have number of columns, so it's a unidirectional, right? And it's a 1D array. If you print that, we have a unidimensional array or 1 dimensional array. So further, let's go to the dimension 2, like 2-dimensional array. Okay, now an array that has 1-dimensional array as itself elements is called a 2D array. See, in 0 dimension we had a single element, right? And in 1 dimension we had a list. Okay, and in 3 dimension we have a list inside a list. Got it? Or we can say we have 2 rows, right? It's normally mentioning the rows. Here we had 1 row and it's 1 dimension, and here we have 2 rows and it's 2 dimensional. Like ting, ting, ting. Make this count like 1, 2 square brackets. We have 2 dimensions. Got it? So why we are studying this? It is it's operational in the matrix one, application to the matrix, right? Next, we have the 3 dimension. An array that has a 3 dimension, like we have an array of 3 dimension, sorry, 2 dimension. If we put this, copy this and paste it inside a list like a square bracket, it's a 3-dimensional array. Got it? As we can count here, 1, 2, 3, and it's a 3-dimensional array. Got it? Cool. Now let's go to the, okay, now we are having a array, but we don't know what is the dimension of that. In this case, we have this like numpy dimension, and which is shortly written as ndim attribute that returns an integer that tells us how many dimensions the array have. Got it? If we use this, we will get, like here we should have 0, 1, and 2 and 3. Let's run this. And here we are getting 0, 1, 2, 3. Cool. Let's clear this. I'm rerunning that. We are getting 0, 1, 2, and 3. Yeah. Now, why we are getting that? See, what is the dimension of that? It's a, right? We are assigning the array into a variable a, and now a is an array, like numpy array. And what is the dimension? We are simply putting an attribute over here, dot ndim. It will give the number of dimension, like dimension integer. It will return an integer, and which is the dimension of that array. Okay, let's move. Why we need that? See, if you're going to print or going to operate a matrix, you don't know how many rows are there or how many columns are there. So in that case, we can't simply loop it again and using the length function again and again. In that case, we can use this numpy dimension attribute. Okay, so let's move on. The next line we have the higher dimensional arrays. So what's that? Let's see. An array can have any number of dimensions. Yeah, it can have any number of dimensions, but in numpy it gives a flexibility to the coder that we can we can limit the minimum 5. Okay, like minimum 5 dimensions you should have. Now simply I'm printing this. We are importing a numpy as an np, and we are having a list. Okay, see, now it's a one dimension, right? It's a one dimension, but here we mentioned numpy should have minimum of 5, minimum dimension of 5. So now let's print it out and let's check the output. Okay, let's print. Okay, wait. Okay, now count it. 1 2 3 4 5, right? Got it? Now what's the dimension over here? It's 5. Okay, let's make it as 10. The minimum is 10. Just run it. What you got? It's 10. Okay, got it? We can assign it. Like we can make that you should have at least 10 dimension, or 10 rows you should have. Like you're going to print something. Wait, let's experiment one. For I we have the array, right? And I'm going to print it. Print the I. So let's see what happens. Okay, it simply printed that. Okay, cool. Okay, man, let's move on to the next question, which is accessing an element. See, remember that in list you had this one, right? We have a list of 1 2 3 and 4, and okay, that's fine. And if you want to print or access it, what do you do? We are simply mention the syntax or position number of that. So in this case it will print 1 here, and in this case we have the same flexibility to access the element inside an array. Like here it is having 1 means 1, sorry 0, it has 1, and if I change this as 3 it will give us 4. So let's test that. See the upper part, right? It is for your reference. If you didn't understand anything, just, or if you want a quick revisit, just go through it for when it comes to the Viva or something else. Okay, something like that. Okay, let's run this. We got 4. Why is that? Because the position is 0 1 2 3. What if we give -1? Same thing applied here. And the list we use this, right? Same thing over here. Now let's move on. So accessing part is done, and we are having, okay, what the one I thought, so which is for the dimension of 1, right? It has a dimension of 1. What if it has a 2D arrays? So in that case, see what we did in list. If you are having a list of 1, right, and another list of 2, what we do, we simply print like 1 and 1, like that, right? Now it is giving the answer as 2. We use this, or in array we will use the position as a list. Like it is saying that you have to get the first one, like the 0, which is this, and the position in that list is 1, which is 2, and it will give us 2. So let's run that too for an experiment. As we are coder, we always use to test the codes. So we got the 2, right? Cool. So further, if you have any doubt, just don't hesitate, right? Just comment below. I will definitely reply with a new video. Now what if we have a negative index? Like it is saying the first one, like position is this one, and the last one from here, which is 10, right? So I can write this as this as well, which will give the number 10, which should give, and it's giving 10, correct? Okay, now accessing part is done. Now same thing applies here. In list you had this property of slicing. Not only in the list, you had these instance also. So here slicing, same, we have start and end and the step. If you didn't give the step, it is default as 1. If you want a different of 2, then we will keep the step as 2. Good. So here we are going to print from 1, like 1 to 5. We have 5 over here, but here the last, wait, where's the stop one? Wait, where's that? Okay, just leave it. If you are having the end is not included in this. Okay, the end is not included. Now if we print it, it will give 1, sorry, 2 3 4 and till 5, not 6. So it's not working. Let's run this. It will give 2 3 4 and 5. Yeah, see, note this, the result includes the start index but excludes the end index. This is what I searched previously. Okay, no problem. So got it. So let's move on. Numpy has its own data type. Like yeah, you may have little confusion over here. Like Python has its right integer, float, etc. etc. Here it is mentioned like I for integer, B for boolean, U for unsigned. The guys who knows C or C++ earlier, it is not a big deal for them because they usually does this, like mentioning the data type while printing or while accessing or while inputting like scanf. Yeah. Okay. So make sure you remember this all, but I don't think you have to remember. Like see, for integer it's I, for boolean it's B, and for unsigned integer it's U, and for float it's U, it's F, and for complex float it is C. For M, like time delta, for M which is M small m, for date time which is small, sorry, upper character of M, and for object which is O upper character, and for string S upper character, and for Unicode string which is upper character U, and for V which is fixed chunk of memory for other type word. Okay, the last one, if we don't have a specified data type to that, it will print that. Okay, now what is the data type inside the numpy? Let's print that out. Sorry, copy. Okay, we have this integer 64. Okay, so let's go on to the next topic, which is converting. Like if you're having a integer, which like let me explain. Wait, see, if you're having a list, L is equal to, like inside that you have an integer, but it's a string. It's a string, right? So for changing that, you can use map or for loops, that and all. Right? For accessing that, you have to do like L and square bracket and the first one, like first element of that array for the list, and you will take a like type of type bracket like that. But in array, like numpy array, we have this flexibility. You have to simply write the array name, like numpy array name, and data type for knowing the, like here, print array dot d type, so d type, right? So if we run this, what we get, we should get, first of all, first one, we should get the float like f, and then we are changing it as type as an integer. So after that, it should show like an integer. Based on that, see, you have the float value. Why is that? We have some decimal points over here, so it's a float. After that, we are changing it array dot as type I. Got it? As type I, we are changing every individual value or element into a integer, and we got this integer 30, so integer 34, so 32. Okay, sorry guys, I usually say this sorry when I make some mistake. Okay, like it's the beginning of this YouTube, right? So that's why. So now we have this copy and view thing in Python's NumPy array. Now copying is just making it a copy, let it duplicate. But view is the same thing, same NumPy, like same array, the original array, I mean the original array which we can access to view. Now here I'm just copying an array, right? Array dot copy, which is x. Good. Now I'm just printing array small, like changing the value 42, means instead of 1 it should be 42. And when I run this, what do you see? Is there any change? No, right? See the last one. Here you have the x, which is a copy, right? Here, which is a copy, we have that. But in array, I simply changed it, and we are printing the array. If it's a view, it should have changed 42 here. Okay, let me check if it's recording or not. Yeah, it is recording. Thank God. Okay, so got it. It's a copy. It's not the original one. It's just a copy. Like if you're buying a mobile, if you make changes to it, will it apply to the entire smartphone of that company in the world? No, right? It's just a copy of that smartphone. If you've done this, like changes to the original source code or the original software to it, then it might change the whole like coding of that mobile. Got it? So it's just a copy or a duplicate or a clone. No, clone is a different thing. Okay, just make sure it's a copy or duplicate of that, but not the original one. Okay, next, check if array owns its data. How we can check? Like I previously mentioned this copy and view, right? This one. We have array.copy, something like that. For view, we can have y is equal to array dot view. View. So if I am having print, like I'm changing something inside this, like yeah, it's already changed. So I'm printing this y over here. So now let's see if it works. See, as you can see, the first one is the array, the original one, and the second one is the copy. We don't have any changes over here, and here we having the original one, right? So I said copy is a duplicate of that, but view is the original one. We are just accessing that. Cool. Okay, so let's move on. Let's close this one to backspace. Okay, it's already closed. Now you have this copy and view, but a programmer who does this thing, object-oriented programming, and he just hided or encrypted the variable. You can't see that, right? Now you don't know that code, whether it's a copy or it's a view or original one. How to find that? Simply, we have an attribute which is dot base. If it's a view like copy, it won't print. It will simply print none. It didn't have any data. But if it's a view, it will print the original array. So let's check that. So now, as you can see, the first one is a copy, which is x.base, and the second one is a, let me scroll this up, and the second one, which is a view. At first one, it's a copy, and that's the difference. Okay, let's move on. Okay, now we are having a shape. Remember your max, like matrices? We have certain shapes. Like we named that square matrix. Like square matrix, we have this triangle matrix, which has a 0 on one side, and we have a triangle like shape over there. But here we are only talking about the shape, I mean a row into column. What if we are simply talking about the row into column? See, the shape of an array is the number of elements in each dimension. Like it will print the dimension also, like the number of rows and the number of columns inside that row. Correct? Yeah, we have a definition for that. Numpy arrays have an attribute called shape that returns a tuple with each index having the number of corresponding elements. Okay, here we took a 2D array for the example. Oops. Let's run this. We have 2 into 4. Why is that? See, remember number of dimensions 2 and number of elements inside that, which is 1, 2, 3, 4. So that's why we got bracket. Okay, bracket 2 row and 4 columns. Simple. And make sure you understand this. Listen to this. Okay, let's move on. So now we know this shaping, but as we are coding guys, we always used to manipulate something, right? So okay, now it has some shape like a row into column. How can I change that? Well, they figured it out. See, rechanging means changing the shape of an array. Like row into column, we have like 2 into 3. We can make that into 3 into 2. Simple. Here we have a one-dimensional array of 1 to 12 numbers. Now we are shaping, but here is a twist. The number you are shaping with, it should be the multiple of, or factor of the total number of elements in that array. So here we have 12 elements, and here 2 multiplied 3, which is 12. So we are going to get that as 4 rows and 3 columns. Okay, what is it? There's a syntax error. Okay, here we have this 3 columns and 4 rows. Okay, let's change this as 2 and like 6, which is also 12, right? So let's run this. We have 2 rows and 6 columns. Cool. Understood? We will use reshape. To know any shape, we will use shape. Okay. So let's move on to the next one, which is reshape from 1D, like 1 dimension to 3 dimension. That's a work of game. Okay, work of play. Okay, let's convert 1 dimension. We have the 1 dimension into what? 3 dimension. So here we are having 3, right? Here we are going to have 2, 3, and 2. Okay, let's run this and see what is happening over there. So here we are having 3 dimensions. Okay, 3 dimension. What is simply happening over here? No, first thing, we are going to have 2 rows and 3 columns and 2. Okay, so let's run this again. Now we are having 3 rows, 2 columns, and again 2 columns. Okay, wait. It is making 2 columns, 3 rows, like 3 rows, and it is making that as 2 dimension. The last one is for the dimension thing. Here, the outermost dimension will have 2 arrays, right? And that contains three rows and 2 columns. The first one is mentioning the dimension. Oh yeah, I got this. Got it. Let's move on. Second, we are having the same question. Right? It's the same thing. It's the same thing. Okay, we have something in the note. There are a lot of functions for changing the shapes of arrays in NumPy, flatten, ravel, and also for rearranging the elements. Rotate, 90-degree flip roller, we have flipboard, etc. This falls under intermediate to advanced section of NumPy. Okay, you are thinking we can't do that? We will do that. Got it? So let's go iterating. So what is iterating? Iterating means going through elements one by one. Which we are having for loop for that. We can use a while loop as an iterator, but we can normally use for loop for that. If you want to print single element or access that with the iterating function, let's do this. Right, run it. Okay, let's clear this junk. You can now print 1, 2, 3 line by line. I want that in one line, not m, and we have a space. Cool. Printing that. Yay. Now let's go back. So got it. Iterating. If you already done the basic Python, you may it's not a big deal for you. Now here's the challenge. For an nested list, what we do, we usually does this thing for loop again, for loop again, for loop again, for loop again, for loop. But in your, if you're having a nested like dimension of 3 or 4, we are having an attribute which is and iterating or iteration of that array. It will simply access 1 by 1, 2, 3, 4, 5. See what's happening here. Just imagine we have a list. Yeah, we have a list which has a nested list into it. Now, if you want to access single thing, right? So what we usually do for I in range, sorry, not in range, L, and again for I, sorry, it's not I, we can A in I, and how many again for K in J, and here we are going to print that K, right? So now let's print that. Let's call the function. Got it? Same thing. See, the bottom line is just the same thing, and here we have to use 3 loops, 4 loops. Here we done that with the 1 loop, single loop. That's the difference. So what we are having, numpy.nditer, which is numpy iteration. You can't say that. Just remember this word, attributes. Okay. So this is done. Let's go further. Close this out. Where is that? Oh, we are running out of the topics. No, we are just finishing everything. Now we are having this iterating array with different data types. Now, can you remember that how we are reshaping, reassigning a data type or changing a data type? And we use that as type, right? Just make sure you are practicing it. Okay. So what is this? We can use of types, arguments, and pass it to the expected data types to change the data type of elements while iterating. While iterating, we can change the function, change the data type of that. That's pretty interesting. What do you have to simply do? We need to make that iterate, and the array name, and here we have the flag is equal to list. Inside that we have string named buffer and opt, objected data type. We can name that, and we are having a string. Okay, so let's run this and let's see, and also make some modification to that and see the changes. So we are having integer, right, inside a string. Now let's make this as f, so it should give a float, but it's not. Why is that? Okay, we have to give the full name of that. Okay, my bad. And now we are having the full name. Okay, again, what's that? See, iterator operator 0 data type could not be cast from. Okay, man, in Managed I will see what's going on here. So let's waste any time over here. Okay, so what we did, we simply changed every data types into string. Got it? Let's pass that. I will make sure upload a video on that topic. Okay, don't worry, we will cover that. So next, iterating with different step size. We can use filtering. See, now I remember one thing. We have this 1, 2, 3, 4. Okay. What is filter? Normally we use this in Python. Filter, and we are going to have some function into it. I can say lambda, right, lambda x, and the x is an full, and we are going to make it as a list L. Now I'm printing that. So let's call this function. What's that? Is there any mistake over here? Okay. We have list. Wait a minute, I have to convert that into list. Will do. Okay. So what we got? 2 and 4. What we did? We simply filtered it. Okay. We simply filtered it. So now, how we can filter the elements in array? Simple. That's why we use Numpy over here. Like it is for filtering, right? So we'll filter like for x in, okay, it's not for the filter, for the slicing methods. Like for one dimension, we can use this as 2. The step is 2. We can use that. What about the 2 dimensions? 2 dimensions. So in that case, if we, let's just remember, if you're going to access 2, 4, 6, and 8. So for we are going to take each and every rows, and in that rows we are going to skip 2 and printing the everything. Like here 1 will print, 3 or 4 maybe. We are having 1, 3, 5, and 7. What we did, we are accessing like in the iteration, one by one the row will come, and in that row we'll take the 1 and skip 2, skipped, then 3, 5, skipped, then 7. Got it? Okay, next one. We have this enumerator, which is used in also the list. When it comes to, you need a syntax for that. You want a syntax with the iteration. In that case, you use that. But here, numpy dot end d enumerate. Okay, so let's run this one and see what's coming over here. So we're having the first index, second index, and third index, as we can see here. Okay, it's for the indexing thing. Let's move on. So you may think that I'm just doing very fast. See, for those guys who already know the basics one, or even in the intermediate level, they difficultly like take 1 hour or even less time to finish all the topics, right? So let's, now we are having this concatenate, simply means joining it. Okay, and list we does this, like imagine we have a list of L1 and L2, and if you want to join that, we can use this, right? But here we are going with this, we're having an array like numpy array, which is array 1 and array 2. We are simply concatenate it, so it simply joined it together. Okay, I don't think I need to run that. Next, joining array using stack function. A stack function, it gives a flexibility, like for making the access, custom access, not this a default one, custom access. We pass in sequence of arrays that we want to join to the stack method along with the access. Here they mentioned the access. Let's simply run this because it's new. We don't use that in a list. Let's run this. So here we are having a dimension, right? We having this. What is that? Can you remember that? A into B. What is that? Okay, the max one. So who are having this max thing? You can see that. Okay, which is called, I don't know. Just remember that. Okay, rows. It's talking along rows. Like, how about just joining the rows? In this, we use this stack, right? Here, 1, 4, 2, 5, 3, 6, all joined up. Okay, but here, what if we want to join column into column, something like that? Like if you want it to join horizontally, we can use headstock. What is the error over here? But guys, we just joined both horizontally, like this one first and this one first. Next, you can see that 1, 2, 3, 4, 5, 6. What is done? Horizontally, it is connected. And what if we want vertically? I think it's V. See, it is connected vertically, up, down, and they're side by side. And then we are having this long column which I discussed right now, which is v stack up and down, like it will join same at this inside adding a dimension to it. Second one, okay, Numpy provides a helper function which is dstack to stack along height, which is the same as depth, like making a symmetric. In my words, making a symmetric. Yeah, it made a symmetric. Correct. We have 3 dimensions and 3 rows. Okay, what if we add something here, like 4, and here also 7? Okay, just in this, and we are having the same thing. Boom, boom, boom. We having a symmetric over here. It is defaultly arranged that it defaultly arranged as like we are having 2 rows. That's why there are 2 columns. Okay, let's make this something. Okay, wait. Let's copy this. Let's copy this thing. Boom. Let's paste it over here. Okay, we can't do that. Let's see. Now we are having that. Here also we must do that. Okay, let's run this now. It's an experimental thing. I never done that before. Okay, what's the problem here? Parent elements must be 2 or 3 tuples. Got 3. Wait, what's it saying that? What is it saying? Okay, yeah, we have to add this one, right? So that's a problem over here. Now it will work. So we are having this 1 4 and 2 5 and 3 6 and 4 7, right? Let's move on. So we are having this splitting, same thing we used in double and also in list also. So here we are having np, which is numpy dot array underscore split. How do you want to split? I want to make it as a pair of 3. Okay, cool, then your order is placed. So let's make that into a group of 3, separating them so that they can fight or somebody can sell the weapons. So we are having 3 groups, 2 2 2. What if I say of 6? No one should group, so then everybody dies alone. The stronger one lives. Got it? Okay, now let's go to the 2 dimensions. Here, okay, here we are going to make 3 groups. Okay, yeah, 3 groups. So how it works, let's run this. Okay, let's delete this junk. Let's run this. We are having how many groups? We are having 3 groups. See, 1 2 and 3. Just count the array letters. Array 1 2 3. Okay, so we are having 3 groups. Splitting here, it is used for grouping. In that case, we can use it as a string inside a string also. Yeah, so here for the grouping purpose. So what if you want that to be grouped along columns? In that case, we will use this extra thing, access one. Let's run this. So we are having group of 3 along the column. Along the column, how it's at? See, 1 4 7 10 13 16. Let's compare it over here. We have this first element, second element, third, fourth, fifth, sixth. Now these the first elements of each arrays inside that are into a single row. Got it? Cool. So let's move further. We are having this searching one. We have that binary search, linear search. So here we are just going to search with a simple thing. In list we had used for loops or while loops, or we can say attributes like count, find, something like that. But here we simply use numpy.var array is equal to 4. Like it's comparing each value. If it's 4, it will take the index of that value. Here, let's see, 0 1 2 3. 3 should be there, and 4 5 should be there, and 6 should be there. Right, let's search that. See, I'm just going with a one go, like I'm recording the whole video in one go. Okay, we have 3 5 and 6. What is that? It's the index number where the answer is matching. Now if I give 1 and run that, as you can see we have the 0. Why 0? Yeah, this. What if there is not the number? What do we get? We have nothing. Okay, So let's move on. This search one, and then we are having this search sort. This is a method called search sorted, which performs a binary search in the array and returns the index where the specified value would be inserted to maintain the search order. See, if you are, I'm having a 4 and I'm having a list which is containing elements till 1 to 10. Now my question is, where should I insert the 4 so that the list would not need a method short method to maintain the order of that list. In that case, we will just use this for loops and while loops. But here we are just having this one. See, now we are having this 6, 7, 8, and 9. Now want to insert 7 so that it is already shorter. So where would I? I would rather insert in 1 or 2 and make it a way over here, right? So I don't know that. I'm asking search sorted. So it will give the index of that. Where should I insert that? So it is giving 1. So it should be 1. So what if I am having 10? So it will give 4. Why? After this. After this, you have to insert the 10 so that it is already shorter. Got it? So let's move on to the next question. Next is search from the site. Linear search does that normally from the beginning of the list. Here array, we have flexibility. If we want to count the integer from the right side, we simply search sorted array 7 side is from the right. See, normally defaultly it will run from here, but here we are having the side right, so it will go like this. So now it should have what? Let's see. Okay, we didn't call that. So we are having 2, right? 0, 1, and 2. All right. So next, multiple values. If you want to search multiple values, what would you do? I simply give multiple values, like where these 2 should insert over in this array so that it's already shorter. Like after 1 and 4 is after 3 and 6 is after 5. So let's run that. Good. Okay, I have an index error. What do you have? 2, 1, 2, 3. It's not printing something like randomly, it's printing. You have to insert the 2 in 1 and insert the 4 after that, after the 3, and insert the 6 before the 7 or after 5. The written value is an array 1, 2, 3, right? Containing the 3 indexes where 2, 4, 6 would be inserted in the original array to maintain the order. Simple. Let's move further. The next topic is sorting arrays. So how we sort? Simple thing, same index but numpy.sort. It is applied in string values, boolean also, or for the multi-dimensions also. So let's run this thing. We are having banana, like apple, banana, cherry, which is in alphabetical order. Here numerical, which is 0 to 0, 1, 2, 3, and true or false. Like false is 0, right? So it's in the first place. We have 1, 1, 1. Okay. So here also it is from the first thing, it is arranged itself. See, 2, 3, 4, and here 0, 1, 5. It is sorted. Let's move further. And if you want every sorting method in Python, I can give that also. We have, like, I started the DSA I think 3 days before and I almost done that thing. Okay, next, filtering arrays. This is what I talked about earlier. Like you have an array, like number array. If you want X and list which has true, false, and the position which is having true will be printed over here. Let's see. It's the thing I like. I like this one. See, 41, 43. 41 and 43. In that place we are having true. What we have to simply do, new array and array name and access this with X, and it will create a new array of the filtered one. Okay, in filter we have an advanced level also. Like instead of that, we can simply create a variable. Inside that we can some operations, like compare operations. the values which are above, like greater than 42, will be true, right? Will be true. Then it will print true, right? Let's see if it's running correctly or not. So we are having 43 on 44, which is above. Okay, now let's run this thing. So we are here we are going simply going to print the even numbers. Okay, so 2 4 6. Okay, so that's it, guys. Okay, let's go for a quick summary. First, we started like with the introductions and starting with the arrays, and we discussed dimensions, how to check dimensions, and we can manipulate. We can say that we have to make a array of minimum dimensions also. Okay, we saw negative like indexing or accessing the arrays with index, and slicing the and data types in Python and NumPy also. Okay, converting data one data type to another, right? We shape and reshape, iteration, de-iter, and we saw copy, view. Okay, and what is how to check if it's a copy or a view, and joining like using concatenate and stack functions. If you want to add like make a array of rows or column along rows along columns, and high depth numpy arrays, splitting things like with 2D or about 2D, and search operations, sorted, search from site, and filtering, and with a function we can make that. And at the end, wait, the end. Okay, guys. So this is all about NumPy. It's not a big deal. Some of the attribute we need to learn and practice, and where to use and how to use efficiently. Okay. So if you already know the list and operations, or made some questions or solved some questions inside the list, or you practice it pretty much, the NumPy would be an like piece of cake for you. Okay, guys. So see you soon on the next video. Next video I'm going to upload about the Pandas library. Okay, guys. See you soon. Thanks for watching. Have a great day. Thank you. And don't forget to subscribe and like and share with your friends, so that they may get some passing marks in their exams, or maybe in the career they are want to build. Okay, guys. Thank you. Thank you so much.